Okay, this is a demo of the sequence of steps you need to do to execute the project for this MapReduce multicast implementation. So the first step is to generate the file that has the 10 to the power 5 integers. So I gave you the data generator Java program. All you have to do is just run it, compile and run it to generate the file with all those 10 to the power 5 integers. So that's what I'm going to do. So I'm assuming you have downloaded that file. I already have the data text file. Let me delete it so it gets generated now. So of course I have implemented the project, so I'm not going to show the code. uh, so the I'm going to compile the data generator Java program I gave you, and I'm going to run it. It takes two arguments, as you can see here: the file name to which you want to store the data generated, as well as the number of integers you want to generate. So the file name you want to store, let me name it as just data.txt, and I want to generate 10 to the power 5 integers. So it generates 10 to the power 5 integers and stores them in this file data.txt. Okay, so and if you open the file, you can see that it is just basically a sequence of integers. Okay, so now what happens is once you have the file, you can make sure it is there. You'll write the code for the multicast and MapReduce as described in the project description, and now I'm going to show you how to run the program. So assuming that you have written the program, how to run it and show me the demo in your video. So I have written the program myself, so that is in this file multicast sender receiver.java. So it is just one single program that has both the sending and receiving features. And so I have 5 process windows open, so you also need to demo with 5 process windows. So as you can see in the project description, it's going to take up these inputs. So let me start multicast sender receiver, Java multicast sender receiver. The number of processes is 5, so the first process gets a process ID 0, so the process ID ranges from 0 to 4, and the number of integers is going to be 10 to the power 5, that many integers that are generated in that file, and it is stored in data.txt. So once you press enter, it should compute the local sum of all those indices that are mapped to this process ID. So basically data at indices 0, 5, 10, 15 and so on. The sum of all those values will be computed, and that's the local partial sum value. So now open in this other process window, let's start process ID 1. So again, the number of processes in this particular process ID 1, and then 10 to the power 5 integers, and then data.txt. So this computes the sum of the integers at index values 1, then plus 5, which is 6. So 1, 6, 11, 16, 21 and so on. Then this Java multicast sender receiver 5 2, process ID is 2 here, 5 is still the number of processes, 10 to the power 5 integers, data.txt. So this is for processes this is for process ID 2, so it reads data with index values 2 plus 5 to 7 plus 5 12, so 2 7 12 17 22 and so on. And then this is with Java multicast sender receiver 5 3 data.txt. So it reads the process reads the data with index values 3 plus 5 is 8 plus 5 13, so 3 8 13 18 23 and so on. And finally this process okay, so now you can all the read threads are basically started, right? So that's what it's waiting for you to press return, so that this local partial sum value, so this is a key value pair, the process ID and the partial sum value. Okay, the the process ID and the partial sum value will be sent as a string to all the processes as you press enter, and then each process receives basically the key values pairs from all the processes, computes the overall sum as well as the uh, maximum of the partial sums. So let's start, you can start anywhere, so let's start with this. So process ID 3 sends its sum to every other process including itself, so every process receives it. And then let's say press for this, and then say press for this, and press for this. So all the 5 processes have sent. So this is the total sum, and it seems in this execution process 2 sent the largest or the maximum partial sum value, and that is the same computed across all the processes because it is consistent, right? So it should be consistent. Process 2 has sent its data to all the sum value to all the processes, and they have computed it. So these are the key value pairs. Let's read from every process, and this is the sum of all those values, and this is the maximum of those values, and the corresponding process ID is printed. Okay, so this is how you should show the execution of your program. So let me stop it.